So that brings us to a very quick demo. Now, some of you saw this before if you saw Anantha's talk on Tuesday. This is one of the Direct3D 10 sample apps, Bump Earth. And right now, we've got it running in hardware, right? You can see the frame rate there. Now I'm going to toggle it to ref. And in this case, we're actually toggling it to warp. Okay, so it's not the ref RAS that originally shipped with the Direct3D 10 SDK. And so you can see it's still got a very nice frame rate. It's certainly much slower than hardware, but it's still totally interactive. It's certainly good enough to feel like you're getting a good rendering experience there. And that's our goal. I mean, we certainly can't expect to be as great as software, but we still want this to be usable. Now, that's kind of cool, and we all like that kind of eye candy thing. But what I'm going to show now, whoops, this seems to have changed. Oh, that's fine. What I'm going to show now is just some sort of office type art rendering examples. And the reason I'm showing these is that because this is the kind of stuff where if you're not doing games, this might actually be more along the lines of the kind of clip art kinds of stuff that you might be rendering. So I just wanted to put those up there. You can see the frame rates at the top. You can see that it looks really nice. It's rendering quickly. So the whole point there is that it's certainly good enough, we feel, to be, again, interactive, performant enough for you to use and feel confident about. It looks good and it's performant. So that's actually the end of the first part of the talk. If you have questions, of course, we can talk about those at the end. But that brings us now to moving on to Direct3D 11, which this is the high-end graphics scenarios. And we have a lot of content here. This is pretty cool stuff. So the scenario here that we're going to talk about is GamerCorp, right? So GamerCorp, they have complex shaders. They have really complicated environments. They have animation going on, lots of characters running around, all this stuff happening. And of course, they want this to happen at interactive frame rates, which is upwards of 60 frames a second. So what are the kinds of things GamerCorp actually cares about? Well, they're worried about scalability. So first of all, Anantha, again, in his talk on Tuesday, he showed this really amazing infographic, if you want to call it that, showing that even within Direct3D 10 cards, there's just a massive performance difference between the low end and the high end. So even knowing that somebody has a D3D 10 card doesn't sort of tell you that much necessarily about their performance. So you want to make it work well on those sort of lower end cards, and you want to make your game really shine on those higher end cards. Okay, so we want to be able to scale on that kind of hardware. Number of CPUs. There's certainly been a ton of talks about multi-core and many-core at this conference. We know that multi-core and multi-CPU is just becoming a way of life. Like even my laptop has 2 CPUs in it. So again, we want to make this scale so that it can really take advantage the more CPUs your end user has. And then display resolution. Another trend that everybody has noticed is lots of people have laptops with very small screens. Lots of people now, if you're like me and you have your gaming PC hooked up to an HD TV, like I've also got a super huge screen. So now as a game developer, what I have to worry about is I need to render it so it looks great on that HD TV, but at the same time, I don't want to render all that content if it's going down to a small laptop screen. Like that's a lot of wasted effort. Nobody can see that. So we need to be thinking about scalability in response to display resolution. Performance is kind of, you can think of that as kind of being a form of scalability, right? Again, we want to make sure it performs well all across the spectrum of graphics cards and, again, across number of CPUs. But performance is, it's so important to us. I wanted to call it out specifically. And the last thing is maybe not so much for this crowd, I'm not sure, but one of the things we definitely hear from game developers is, hey, you're Microsoft, and you guys do DirectX, and you do the Xbox, but it's not really this ideal experience developing for both of them if I want to develop a PC game and an Xbox game at the same time. So one of the big things we're working here to make much better is ease of cross-platform development. And in this case, cross-platform means between PC and Xbox 360. So here's all the stuff we're going to talk about with this new graphics pipeline. And we're going to start off with a new feature called tessellation. So this is a potential character authoring pipeline. for a game. You might start off with your sub-D modeling, and then you're going to take that and animate it. And then you're going to add high-frequency detail with a displacement map. Now, you could actually do the displacement map before the animation, but you get the idea. This is just a general thing. The sad part is, now what you do is you take this and you dump it out to a polygon mesh. So you did all this modeling in one space, and now you're actually going to render it in a different space. And you might actually generate different levels of detail, but the idea is you've still got these sort of basically fixed polygon meshes to be dealing with. So we think about that pipeline in conjunction with some trends. And the first trend is that, of course, the characters are just getting more complicated, right? They're getting more detailed, denser, more triangles. Okay? So now we've got more triangles, and we add on to that the fact that we're actually putting more animation information on the vertices of those triangles. So not only do we have more vertices, but now we actually have more information attached to each of those vertices, right? Because we're expecting more complicated animations, better looking models, better looking characters. So the upshot of this is sort of two problems. The first one is that now that indirection of sort of doing all your modeling and animation in one space, but then actually rendering something that had a different domain becomes more painful, right? If there's any data loss in that conversion, okay, well, it only becomes magnified the more triangles, the more animation information you have. So that's kind of painful. The other thing, which is probably more visceral in a certain sense, is the I/O issues. So now we've just got much more data, which means it takes us longer to get that data from disk to main memory, and from main memory across a tiny little bus to the GPU. Okay? So this is really causing I/O, like significant I/O pain. So the solution is basically we want to be able to use these higher level surface representations longer, and that means adding tessellation to the Direct3D 11 hardware pipeline. So what we're doing is we're still taking this, but now we take all this information and basically send that to the GPU, and then we can tessellate that at runtime. And here, when I say optimally tessellate, it might mean a couple of different things depending on the scenario. So for example, we talked about laptops, right? Or if you're rendering the character to a small display or the character's far away, right? You don't need to create that many triangles. Okay? And with a fixed mesh, there's already a lower bound on the number of triangles, and you can't go beyond that. In this case, hey, you can go as low as you need to go. Conversely, if I'm on that great big HD TV, then great, give me more triangles. Or maybe I'm like zoomed in to the character, in which case I'm only seeing a little patch. Well then fine, just render that patch with lots and lots of triangles. But you don't need to worry about the other ones. Another way to think about it is if you find that performance is suffering, okay, I'm going to drop visual quality a little bit in order to keep my frame rate consistent. So you have all these sort of controls that you can have